ones, if you're not logged into Alex, you need to log into Alex because you need to use the Alex calculator. Last time, way a long time ago, like the 27th of February, we did the Z-score distributions. Today we're doing the T distributions. You use the Z-score when you know the standard deviation. You use the T distribution if you don't know the standard deviation. And so it's going to sort of work the same way as what we did last time, but just a different table that you could use, or in this case, the Alex calculator. So let me know when you get to the Alex calculator. It doesn't matter what problem you're on, just go to whatever problem's there on your pie chart, and then hopefully the calculator is active. Are we ready?
Yep, come in.
All right, so last time we talked about having that normal curve and that we have a critical value of where it falls. And so on the Alex calculator, the T, if you look for the T, you're going to have something that looks like this. P of T is greater than, right? So when they're calculating the critical value, they're calculating the values to the right of that line. If you're going to do a less than, like we are on this first one, we have to do 1 minus that value. P of T is less than, or is, I have to flip my sign around, greater than 1.87 in this case. The whole curve would be 100%, that would be 1. We would subtract off this part to the right if we want to know the part to the left. So on the Alex calculator, you're going to type in 1 minus, and then you're going to do the P of T is greater than your 1.87, since that's what we're computing. And it says the degree of freedom is going to be 8, so you'll see a little DF and you're going to put an 8 in there. And you're going to just punch that into the calculator, hit equals, and round your answer to 3 decimal places.
0.049.
That doesn't sound right. Well, clear that out for me. So 1 minus, and the P of T, yep, that's the one, of 1.87. And the degree of freedom is supposed to be 8. That looks better. I don't know what happened before.
Yeah. 951.
So 0.951. Anton, are you getting that answer too? Got that figured out on how to punch that in? Not logged in yet, thinking something else? Oh, it's still looking at what you need to hand in yet. All right. The next one, we are going to find the value in the middle of 2 numbers. So we have our curve, and we have 2 values here and here. We know that the part in the middle is 0.99, and we need to find out what these values here and here are. So first thing we're going to do, because we know the whole curve is 1, is we're going to do 1 minus 0.99. If you do 1 minus 0.99, it's going to leave us the area on the 2 outside spaces. If you do 1 minus 0.99, you're going to get 0.01. Now, because that is both of these 2 spaces, and these 2 spaces should be the same size, but I can't draw, I'm going to divide this by 2. So if you take your 0.01 and you divide it by 2, you get
0.005.
Okay, so the area in this section is 0.005. The area in this section is also 0.005. Since I'm finding the area, now I'm going to use the T sub, the one with the little box. See that one on the Alex calculator?
Yep.
So I'm going to put T sub 0.005. Again, it's going to ask for the degree of freedom, and on this one it says 22 is what we want to use for our degree of freedom.
Oh,
2.819. 3 decimal places again, it says. 2.819. Okay. So, 2 is one where you're finding the area under the curve. That's what the P of whatever. You're finding the area in that spot is 0.951. Or they give you the area and then you have to find out what the critical values are. That's why they use the C for critical value. 2.891. So if we look at the next one, number 5, this one we're between the two things again. So I've got my curve. We've got our two critical values, negative 1.29 and positive 1.29. And we want to compute that. So if we're going to compute that, first thing we're going to do is, and they're doing the less than, but we're going to find the area just in this little section right here. So we're going to do P of T is greater than the 1.29. And I suppose I didn't put my degrees of freedom. 18. I better put that. There, we'll add that on there. Degrees of freedom should be 18, it says up there.
107.
So, this I'm going to carry a little farther because at the end we want to round it off to. So I use 0.106689 and figured that was good enough. So the area in this section is 0.106689. The area in this section is also 0.106689. We want to find the area in the middle. So we're going to take 1 minus 2 times that value because we have that on both ends, right? To find the area in the middle. And then this one we can round off to 3 decimal places since we're at the end.
787.
Yep, 0.787. And they do give you a little wiggle room on the rounding because sometimes it will tell you in the problem of how far to carry out your rounding, and this one it doesn't. And so sometimes they give you a little wiggle room when you do your answer. So the next one is one where they give us the area, and this happens to be a less than. So I have my curve, I know my area less than this is 0.05, and I want to find out what that critical value is. So I'm going to find this part right here. If this area is 0.05, then this area would be 1 minus 0.05. Or 0.95, right? We now want to find the critical value, so we're going to do the T sub, and then we're going to put that 0.95 in there. Degree of freedom is going to be 12. When you do the area, it's always to the right. So if they give you the area to the left, you got to find the area to the right by 1 minusing that number, and then that's what's going to go in the box. So if you do T sub 0.95 with degrees of freedom being 12.
Is it a negative?
Yep.
Negative 1.78.
Exactly. So this critical value here would be negative 1.782. All right. So number 6 looks sort of like number 4, at least to begin with. Again, they give you a less than because they want you to get used to the calculator doing greater than. If it's a less than, we're going to do 1 minus that, right? So I'm going to do 1 minus P of T is greater than 1.34 with my degrees of freedom being 20. Zero point, did you say?
Yeah.
9, no?
Or, you know, 0. 0.098. No, 7.
Let's see what you got typed in there, because that's not what I got. All right, clear that off. Yep. So 1 minus, we can do the 1 minus, okay. Since it's a less and we want a greater, 1 minus, and then 1.34 with a degree of freedom of 20. Whoops, and you hit there. Hit undo. Whoops, undo is right next to the clear. Now hit equals. There we go, that looks better.
Where we at?
We are on homework 14, chapter 7. We're using the Alex calculator again. So, yep, there's chapter 7, we're your homework 14. Now we gotta get to the Alex stuff. Keep going, that's from the book. There's homework 14. All right. And again, this is just like on number 4 where we're doing the 2 critical values that are going to be the same number. We know the area in the middle is 0.9. So we're going to find the area on each of the 2 ends. So again, first we started with 1 minus 0.9, which gave us 0.1. Since there are 2 sections, we're going to divide that by 2. 0.1 divided by 2 gives me 0.05. That means that 0.05 is the area of each of those 2 sections on the end. We then want to find our critical value. So we're going T sub 0.05, which actually gives us the right here. And my degree of freedom, this time it says we're using 2. So T sub 0.05 with a degree of freedom of 2. And these you punch into the Alex calculator, so you might want to log on there.
Oh, okay.
2.92, and they're actually going to put 2.920 just to throw the third decimal place in there. But if you put 2.92, you're probably still okay. All right. So last time when we had the X or the Z scores, they had those same kind of things, only now we're doing T's instead of Z's.